Okay, so this is a presentation of conditioning paradigm for appetitive and aversive conditioning in humans. We used two-day paradigm. The first day was only appetitive. The second day was only aversive. It was a partial conditioning, not fully reinforced. So only 10 of 16 reinforced, 10 of 16 CS passes were reinforced. And there were also CS minuses. So how it actually goes, this is the plan of the conditioning. First, the participant had the habituation phase. During the habituation phase, they were presented with the 4 CS pluses and 4 CS minuses without being reinforced with anything. And then they had the questionnaire. And then after the questionnaire, they have this main conditioning session, which consisted of 2 parts, the acquisition phase and the reversal phase. In the reversal phase, CS plus turns to CS minus, CS minus turns to CS plus. In general, if somebody does not do the conditioning experiments, what we do here, first we have the conditioned symbol. In this case, we had 4 types of 4 different symbols to use as conditioned symbols. This is the square and the diamond, and the trapeze and what we call rhomboid. So to create CS plus of the CS minus or CS minus of the CS plus, we just turn it like 45 degrees. All those symbols were randomized in counterbalance between participants and phases. So if the participant has some symbol as CS plus, like the diamond and the square, so that for the CS minus, on the next day, the participant had the rhomboid and trapeze, and vice versa. There was no interruption between the acquisition and reversal phases, and it was not known by the participant. So that it's gonna be the reversal phase. So how it actually works. We first show the participant the symbol, which means nothing in the beginning. Then after a certain period of time, in our case, after the 6 seconds, we show the condition symbols, which is either money in appetitive conditioning or electrical stimulation in the aversive conditioning. And after a certain time of repeats, after several repeats, actually usually in the second phase of conditioning for this actual paradigm, the conditioned symbol CS plus caused the conditioned response, which actually means that it caused the same reaction which was previously caused by the unconditioned stimulus, like the money or electrical stimulation. It's a little bit it's a little bit not clear, but a little bit not so precise with the money, because we actually don't know what is the pure unconditioned appetitive symbol stimulus, because the money is to some extent the second level conditioning, we may say. So the people are already conditioned to money. Anyway, so the first day goes. Also the day were counterbalanced and randomized between participants and their genders. So first participant is conditioned to the CS plus, then after reversal CS plus becomes CS minus, and the participant kinda is conditioned in another way to the symbol that previously was CS plus, and the CS minus is actually in the previous CS plus is actually in the phase of extinction. So the reversal phase is the kind of acquisition mixed with extinction of previous symbol. So it's also called counter-conditioning. During this, we measured pupil size and EDA, heartbeat, PPG, and breathing rate. In this analysis, I'm presenting the data actually mainly for the pupil size and EDA. So this is the main paradigm, how it goes. And now a little brief reminding about the actual anatomy of the nervous system. So in this case, we're interacting with the sympathetic nervous system. There are some thought that it can be not only activation of sympathetic nervous system, but also depression of parasympathetic nervous system. But mainly the effect that we observe, the dilatation of the pupil size and the increased EDA response due to the arousing event, which we believe that showing people the money and giving the money to the people and exposing them to electrical shock, other arousing events, and they cause the activation of sympathetic nervous system, which we can observe by detecting the increase in the pupil size and the increase in the EDA response. So on this level, we are not sure. So we believe that the showing the people the money is appetitive. So it's a kind of a arousal, positive arousal, and making them feel pain with electrical stimulation is a kind of a negative arousal. So they don't like this. But anyway, the response of the nervous system, I will say on the segmental level, so on the level which is below the cortex, is pretty much the same. So a brief anatomy, what actually happens, where are those sympathetic nerves which make the pupil size to dilate and which make the skin EDA to increase, which actually mean that the level of sweatness increases. So where are they going from? So the first, like the peripheral component, is the sympathetic chain ganglia. So the sympathetic chain ganglia, which actually contains all the sympathetic ganglias. So before the ganglias, before those sympathetic, it's called also sympathetic truncus. Before the sympathetic truncus, we have the preganglion sympathetic nerves, and after we have postganglion sympathetic nerves. In the case of a pupil, so the musculus which dilate, muscle which dilates pupils go from the superior cervical ganglion, which is the, may say, the first sympathetic ganglion, and the nerves which go to the part of the skin where we measure the skin conductance or ADA. It actually goes from the level of C8 T1, so I would say a little bit, they're quite close. And so we're measuring the level of sweatness on this area, which is innervated by nervus ulnaris, and which has as its component the sympathetic nerves, which also go from here. And on the level of spinal cord, they begin in the ventral horn of the nucleus intermediolaterales. So in the ventral horn of their spinal cord, in the structure which calls nucleus intermediolaterales. So this is pretty much the same for their for those nerves which go both to the eye and to the sweat glands. But anyway, even though those nerves are different, so before they go to this peripheral level, they go through a lot of central components. And here actually you can see those central components on the cortical level and on the subcortical level. Here they are kind of all mentioned. And what is interesting, a lot of them, so these are the central autonomic network, which origins in the cortex, also mainly in the arterial cingulate cortex, go through hypothalamus, which is one of the main, we say, regions where all those centers are collected, which regulate autonomic nervous system and the and its sympathetic part as well. They go through the brainstorm, to the spinal cord. And what I was trying to show here, that here we see the sweat gland, sweat gland, and here we see the smooth muscles that goes to the pupil as well. So those are different nerves, which on the level of brainstorm, they have different components, and they've been impacted. They have associations with different parts. So though they are kind of pretty much the same parts of the sympathetic, they are pretty much the same part of the sympathetic nervous system on peripheral level. On the higher levels, they are different, and they are influenced by different centers. One of also which, but the components which are similar are this truncus sympathicus, nucleus intermediolaterales, it's Latin, so, and this main part which is called nucleus ceruleus, I always pronounce it in the wrong way. So actually this nucleus, it's somewhere here, and it has connections with the almost main component of the brain, which I believe to play some role in emotional states. So it's connected with the ventrotegmental area, it's connected with the cerebellum as well, it's connected with the limbic system, so with all those stuffs. Here once again, the main centers of the autonomic regulation, which also are associated with a sympathetic, which also have, I would say, that give some innervation to the sympathetic components, which go to the sweat glands and to the ciliary nerves, which dilate pupil. So this is hypothalamus, yeah, the main part. Actually, actually posterior part of the hypothalamus, paraventricular nuclei. Mammillaria body, mesencephalic radicular formation, pontine radicular formation, mammilotegmental tract, raphe nuclei, and a bit lower there is this locus coeruleus. In more detailed, yeah, so the generalized heme for the eccrine sweat glands is hypothalamus, then it goes through pons, through the medulla reticular nuclei, so those nucleus intermedio lateralis in the spinal cord, and then paravertebral sympathetic ganglion, which is level C8 T1 in the case of sweat glands, and the same components in the case of dilatation of the pupil. So it's a hypothalamus, locus coeruleus as well. It's not mentioned here, but it is. And then it goes to superior cervical ganglion. For some reason it's lower. So intermediolateral column also as well, and then it goes to superior cervical ganglion, yeah, and through nervi ciliaris, through ciliary nerves, it goes to the pupil. So that's what actually happened. And when seeing the dilatation of the pupil and when seeing the increase of the EDA, which is the increase of the eccrine sweat glands activation, we actually see activation of this chain. But my main point was that this chain is how to say, these two both components of the sympathetic nervous system, they have a lot of similar, and they have a lot of similar centers, but in the same way they have connections with different parts of the brain. So the idea that they react in a different way, which is kind of an obvious thing, that they are working like separately, but something that I wanted to show, that anatomically they have similar parts, and they stay something like they have something that they share and something that's specific for those systems. But once again, generalized heme, it's kind of a huge, but what the main to show. So the sympathetic nervous system has its representation in the cortex, then it goes to hypothalamus, to the paraventricular nuclei, then this main part, locus coeruleus, and then to preganglional, to truncus sympathicus, yeah, sympathetic ganglion, and the sweat glands, and to the iris, dilatation of the pupil. So the pathway is the same, but on the path in the brainstorm, for example, so spinal cord is pretty much the same, but in the brainstorm they have how to say, I've forgotten the word, not incomes. They have inputs from different parts of the autonomic nervous system on this suprasegmental level. And here's once again this locus coeruleus, which they have in common, which actually associated with pretty much everything. Substantia nigra, vitae, cerebellum, yeah, a lot of the regions in pons and medulla oblongata, and in cortex as well. So that's what a short anatomical reminder. And now we go into actual study. What should be mentioned, so before the study, before doing the pilot, so this actual study is as well the pilot study for the MRI. So before doing the functional MRI study, we're doing this paradigm to check how the paradigm works, if there are conditioning or not. And in the process of making up of the design, it was decided also to do the pilot of the pilot, actually pre-pilot study, which is not conditioning study. In this pre-pilot study, what we do, we just showing people or like exposing them to 4 different USs. It's actually 3 of them are appetitive and 1 is aversive. And the idea is to see these responses, the behavioral responses, how the people react on their different money amounts, compare it with how they react to the pain, and also see the how will they cognitively react on this. So we had the questionnaires, and after each stimulus, they had to answer the question like, how do you feel about that? So what it looked like it was 4 blocks with 4 different stimulus, and the stimuli were randomized inside each block. So they were not all randomized to avoid, for example, 3 in a row similar symbols. So they were randomized inside the blocks. So the stimulus is the question about the fear, arousal, valence, and stimulation. Stimulus, questionnaire, stimulus, questionnaire, stimulus, questionnaire. So during all this time, we also check the ADA, PPG, ECG, and the pupil size. The main measures that we checked are the questionnaires and the pupil size and the EDA. And okay, what we have in the end. So these graphs represent the means and the standard error for reaction to electrical stimulation, €5, €2, €1, in the terms of pupil size change. So how the pupil size changed in size in the response to electrical stimulation and the money. The overlaid scatter plot is actually each response separately. So all the responses the patient showed, they are like here, overlaid. Mean are represented as in the millimeters multiplied by 10 in the 3rd degree. So 1000 is 1 millimeter. What can we actually see like visually here? So if we take all the stimuli, there were actually 4 of each. So each participant had 4 electrical stimulation. 4 times he was presented with a €5, 4 times he was presented with a €2, and 1 time he was presented with a, or 4 times he was presented with a €1, and there were like 20 participants. And what we can see by building the mixed model. So here I built a mixed model because we have the repetitive measurements. So to avoid correlated errors, which probably will correlate, most probably will correlate because for the measurements of the same participant. So we've built the general mixed model, and here the €1 was taken as a reference dependent value. So we have one fixed value, which are the subjects, 20 subjects, which had the random effect. We had one value which had a random effect, the subjects, and the fixed effects. Here is one fixed effect. It's actually the modality and the valence of stimulus. And we can see that electrical stimulation was significantly higher than the 5, 2, and €1, and there was no difference between 2, 5, and €1. So the reaction to those stimuli, we can see here that for €5, it's actually even less for €5 than for €2 for some reason in general. But the highest, but they are still not statistically different, not significantly different. And the highest is for the electrical stimulation, and it's like 0.26 millimeters higher. So 1/4 of a millimeter, half of the half. Okay, what can we do next? Next, we can look at all those things by blocks. So here we kind of we had the 2 fixed effects. So previously it was 1 fixed effect, which is the value, and now we have 2 fixed effects. That is the block. 1 fixed effect, it's first, second, fourth, or the third, and second fixed effect, since previous is the value. The random effects is still the subjects. So this is the same mixed model. What we can see here? We can see here, so in general, statistically higher, the values are in first block are statistically higher, and the values, the electrical stimulation is also higher than 2, 5, and 1 euro. But still there was no kind of, also when checked with an interaction with these two variables, there was no any significance. So for now we can say that the only difference is that in the first block, the responses for pupil size are a little bit higher, and they're still higher for the electrical stimulation. Here we actually can see some kind of a habituation, so that there is a obvious decrease of response. So the people react not as intensively in the last block. Still will remind that that's not a conditioned paradigm, that's still we just showing the people, exposing the people to the unconditioned stimuli. Okay, when we analyze data inside each block, so now we're taking only like the first block, and in this first block we're doing the same which we've done here. So here we've done the general mixed model for all 4 blocks, and here like block by block. And once again, in first block the electrical stimulation is higher, then the 2, 5, and 1 euro. 1 euro is taken in the reference. In the second block there was no difference. In the third block, electrical US is higher, but the reaction estimated response is lower. Like it's in the beginning it was like half of a millimeter almost, and now it's like 0.3. And at the fourth block, once again, almost no difference. There is only like trend-like, you can say trend-like difference. So electrical US still a little bit higher. What we can do next? We can check them by the, also not only by the blocks, but the order of appearance. Here it's a little bit harder because, as I told you, randomized inside the blocks, so we have the different number of observations. For example, 1 euro, after 1 euro it happened only one time. But still we analyze this and also saw some kind of a patterns. How we check this? So there are 5 different positions where the stimulus can be. It can be first in the trial, actually first in the experiment. It can go after 1 euro, after 2 euro, after 5 euro, and after electrical stimulation. In general, it's already can be seen that in most situations, if the stimulus was first in trial, it mainly caused higher reaction than the stimulus of the same intensity if they were not the first in trial. But it seemed that there was no significant difference or high difference depending on after which previous symbol they were presented. So the main difference we see that for the electrical UA, for the electrical stimulus, it was significantly higher than the monetary reward as well. And the order of appearance, when we take the fixed effect as the order of appearance as the second fixed effect, second predictor, we see that so only if they go first, they make some effect, and this effect is the other effects are not significant, and they estimated really low. And now again we analyzed like previously after previously. So now we're analyzing not by blocks but by values. So let's first analyze the 1 euro. Yeah, and here we can see that 1 euro had lower effect when it was after 2 euro, and 1 euro had lower effect when it was after electrical stimulation. Then 2 euro it has lower effect when it was after 1 euro, and has lower effect when it was after 5 euro, and it had lower effect when it goes after electrical US. Nothing different for 5 euro, and for electrical US all the values were lower if comparing with the first in the trial. So in general, as a reference value, we take here when it was first in the trial. What can we say? That for €5 it's not important whether €5 was first in the trial or not first in the trial. It's not it's not very significant where the €5 is. So €5 caused the same probably reaction, not depending where it was. For all the others, for electrical stimulation, always the first stimulation was much higher than the others. First response to the electrical stimulation when it was first in the experience was much higher than comparing with the other positions. And what else? And yeah, for €2 and for €1 also, the first in trial was higher, we can say, but not always. Okay, let's continue. No, these are some tables that I probably will delete. They're not telling anything actually. Now the same thing for the EDA. Once again, the same for the EDA, and EDA actually shows the same. So they're different. There was no difference comparing the €5, €2, and €1 response. Only the electrical stimulation was higher. And once again, comparing by blocks and the electrical, comparing inside of the blocks, only block 1 caused higher reactions. Once again, pretty much the same pattern, when comparing inside the values with the different positions. Okay, now we ask the people the questions. I don't have the statistics for this, but what can be observed, so the idea was to pick up the same level of aversiveness and pleasantness. And here we can actually see that when the people rating the STEAM evaluation, which actually asks, so for money, it says like pleasing and unpleasing. So I am pleased and I am not pleased, meaning that I am not, so it's kind of we mean that this is a neutral. So for the money, -4 is I am pleased, and the 4 it's I feel nothing. And for electrical stimulation, it's kind of a -4. It's I'm kind of a neutral. I'm not feeling bad, and 4 is I'm feeling bad. Originally the scale was from 1 to 9, but we shifted a little bit the values to make it possible to compare. And what we actually can see that the €1 causes the same level of pleasantness, which is caused by the electrical stimulation unpleasantness. So €5 and €2, they are more pleasant as people respond than as they cognitively respond, because behavioral responses are the same for €1, €2, and €5. But when they answer the question, they actually rate the 5 and €2 higher than €1, and the absolute values are higher than the absolute values of the electrical stimulation. Let's then look to the other answers. So if we ask them to write the valence, angenehmen und unangenehmen, I've forgotten what it was. Actually, once again, the €1 is in absolute value is closer to electrical stimulation. When we're asking about the arousal, for arousal it's not very clear, and for fear it's not so clear because of the question, because nobody fears of the money. And the level of arousal, actually the main thing that we are measuring, so they are measuring the level of arousement of a sympathetic nervous system, but as well it's not so easy to find something up, because anyway, money does not cause, which people say arousal. Maybe it's about the question. So if I ask, are you aroused by money? So if you're happy by money, yeah, I'm happy about that, but are you aroused? Well, people say that they are not aroused. Not actually, we see the activation of sympathetic nervous system. It means that they are aroused to some extent. That's the same plots, but generalized in one. Those are the same plots, but block by block. Actually, I will skip it. The pattern is pretty much the same. So here data are shown for all 4 blocks together, but we ask them the question after each block. So we have the questionnaires, for example, for fear. For each block, let's check which is the closest. Is it for example, steam evaluation? Let's see the steam evaluation. And what we see that the steam evaluation, like €1, and electrical stimulation minus 2, minus 2, minus 2, minus 2, once again, sorry, minus 2, minus 2, minus 2, minus 2, 1. Now, what we can observe that the habituation to electrical stimulation is more visible in the terms of the questionnaires than the habituation to the money. So the pain becomes less painful, but the money are still money. Okay, and now after all this, we decided that we're gonna use, if there is actually no difference shown, we're gonna use €1 as the appetitive stimulus in our actual conditioning paradigm. So as I've told already, we've used those symbols. So let me check the time. Let me check the time. Oh, half an hour, actually. Great, I thought it would be more time. Okay, let's continue. So this is the one trial, and this is the intertrial interval. So intertrial interval, the fixation cross was presented during this intertrial interval, and it was randomly changed from 7 to 11 seconds. Then we have the actual 7 seconds of presentation of CS plus or CS minus, and the last seconds was overlapped with the appetitive or aversive stimulus, and then we once again have this intertrial interval. When we measured US responses, we measured like the first 3 seconds after the stimulation, and for ED and for pupil size, and the same when we measured CS responses, we actually measured the last 2 seconds. When we, I may say that we actually measured the whole interval, so we just measured from the second 2, 3, 4, 5, 6. So from second to 6, from second number 2 of the presentation of CS, the CS response, conditioned response was observed. Most often it was observed here, but still we measured all this interval. As a baseline, we've taken like 0.3 seconds of the 0.3 seconds before the presentation of conditioned symbols. This was for the pupil size, because this is the time period where the pupils are least impacted by the light. Also, we tried to make the conditioned and unconditioned stimuli the same level of luminescence to not cause responses just to a change of intensity. So this is how it looked, like trial by trial. As I've told, we had this 32 trials of so this is without the habituation. Only in the beginning of each acquisition set we added 2 CS plus, CS minus not reinforced, like the second habituation, because they have the questionnaire after the first habituation, so to make them like habituate once again. So this is appetitive 1 day, and then appetitive reversal, and on the second day there was the aversive. And once again, the days were randomized between the subjects. If one symbol was used for appetitive, it could not be used for aversive. So 32 trials of actual conditioning in initial and reversal. 10 of 16 CS pluses are reinforced. So 6 are not reinforced. Here they like 1, 2, 3, 4, 5, 6. So 6 CS pluses are not reinforced and 10 are reinforced. The same, so the paradigms are completely the same. And the first results of conditioning. Okay, let's see on the aversive pupil size response. So these are pupil size. This once again millimeters, 0.001 millimeters. So this actually 1 millimeter, 1000. Here you can see the trials. The middle, the black line is when this reversal starts, when the symbols changed. So in the first half, the and all the dots are the mean responses for all participants for the trial. So this is the mean response of 20 participants for the first trial, for the second, third, fourth, and so on. In the first half, CS plus is red, and then it changes, and CS plus is green. So this is the, once again, this is the response to CS. This is the not response to unconditioned stimulus. So this is the not response to the stimulus. So this is not this reaction which is observed in this time, but this is the reaction which observed in this time before the presentation of US, during the presentation of CS. Well, we can see that there is actual conditioning, but for aversive stimuli, the conditioning is very, I would say, fast. So they became conditioned to the electrical stimulation, and almost from the beginning of the experiment, even in the first half, like during the first 16 trials, we see that the red line is higher than the green. Then the green kind of becomes higher, and for the red line we can see something that we can call the extinction, because this is actually the extinction of the previous CS plus, which now has become CS minus. And there is the conditioning for the reversed symbol. Okay, what can we do right now? We can compare those. So here the red is CS plus and the blue is CS minus. It once again showed as the median and the standard error. The median and the standard error. First two columns, first four columns are initial. The second part, the other columns, second four columns are reversal. The first two columns are first 16 trials, then these 16 trials, 16 and 16. So we don't take in account like these first two trials of the second habituation, which goes before, just before. Oh, even visually, the CS plus is different from CS minus just from the beginning, and this difference kind of decreases in the reversal. This once again is analyzed for, so here the color is changed, so CS plus is green, but here CS plus is CS plus. So CS plus is always red, so that they are the symbol. The condition is pretty fast, so the are different just from the beginning, and we can see when taking as a fixed, as a random effect, we take the subjects, and as a fixed effect we took the CS plus and CS minus, so the stimulus and the conditioning beginning or the conditioning end. So not the acquisition and reversal, but here we're comparing the first half of the initial with the second half of the initial, and the first part of the reversal with the second part. In this mixed model, we're taking into account only, only initial. So this is all aversive. So we're taking into account only initial phase, and we can see that for initial phase, the CS plus is higher in both, in the first 16 trials and from 17 to 32, but there is no difference in the beginning and the end. So when taking the end and the beginning of the experiment of this phase as a fixed effect, there is nothing different. Okay, I'll make a short break. Very short, or not very short. And then continue after the break.